অ্যাটমিক নাম্বার ইনক্রিজ করে, অ্যাটমিক নাম্বার ইনক্রিজ করে। ফোন নাম্বারটা মুছো না, ফোন নাম্বারটা মুছো না লাস্টে। হয়ে গেছে। অক্সিজেন, সালফার, মানে দুটো দুটো অক্সিজেন হবে, O2 হবে। Today I haven't read anything. I've taken rest today. I've visited to my maternal uncle's house. Today is Jamai Shoshti. I think Mr. is Jamai Shoshti, so we have celebrated. ইনক্রিজ করবে। melting point. Oxygen, sulfur, selenium, chromium, chromium. দুই দুই দুটো দুটো আছে দুটো আছে দুটো আছে Four. হয়ে গেছে হয়ে গেছে দুই ছিল। আট। স্ট্রং হবে। temperature. High temperature. বেশি হাই টেম্পারেচার। স্ট্রং হবে আর মেল্টিং পয়েন্ট বলিং করে। আটটা অনেক বেশি। লেখা হয়ে গেছে। হয়ে গেছে লেখা, লেখা হয়ে গেছে। হ্যাঁ so who is here? Don doing replying. This class is very important. Okay. आप कहाँ से हैं? I'm from West Bengal. So though I'm doing my class, I can't reply. I'm from West Bengal. I cannot say anything else now. Okay. So those who are new, please subscribe my channel. Let me revise coordination compounds now. So importance of coordination compounds. You can open your coordination compounds chapter and can revise with me if you wish. So the coordination compounds are very important because coordination compounds are widely present in everywhere. Okay? They are widely present. So coordination compounds are widely present, and where they present? They present in the minerals, they present in the plants, and they present in the animals world. So coordination compounds play important roles in the area of analytical chemistry, in the metallurgy, biological system, industry, and medicine. Coordination compounds find uses in qualitative and quantitative chemical analysis. Coordination compounds are very important. So coordination compounds find uses in qualitative and quantitative analysis. How the color retention form. So when there is tirating ligand plus metal ions, it forms the coordination entity. So when there is tirating ligand plus metal ions. So tirating ligand plus metal ions form the coordination entity. Here the coordination entity means the coordination compounds. It forms the basic for the detections and estimations of ions by the chemical and industrial method of analysis. So it forms the basic for the detection and estimations of ions. And ions are of two types. What are they? The ions are of two types. First one is cation, second one is anion. By the chemical and industrial method of analysis. So examples are EDTA, DMG, that is dimethyl glyoxime. It contains nickel, alpha nitroso and beta naphthol, and fourth one is the cupron. So hardness of water can be estimated by titrations with Na2EDTA. Now the Ca2 plus and Mg2 plus form the stable complex with EDTA, and calcium and magnesium, they are the group 2 elements. So when calcium and magnesium with EDTA form the stable complex. So calcium, magnesium with EDTA form the stable complex. The selective estimations of ions can be charged due to difference in the stability constant of calcium and magnesium complex. The selective estimations of these ions can be done due to difference in the stability constant of calcium and magnesium complex. Some important extractions of metals. Okay, some important extractions, as we know that gold and silver are very precious. So these are the important metals. They are the most valuable metals. So some extractions of some important extraction process metals, that is gold and silver. So gold indicated by Au, silver is indicated by Ag. Now makes the complex formation. So silver and gold extraction from the complex, that is the coordination complex. Gold and cyanide with oxygen plus water, and it form the aqueous solution. So it will form, the result will be AuCN2 minus. Now from this solution, gold can be separated with the help of addition of zinc. So when we add zinc with AuCN2 minus, so we can take out zinc. We can separate zinc metals. So purifications of metals can be achieved through the first one is for formation, second one with the subsequents, and third one, first step is the decomposition. Purification metals is achieved first one through formation, second one formation and subsequent, third one is decomposition. Yes. So the pure example is the how can we extract the pure nickel. So pure nickel can be extracted from the impure nickel by first thing is that impure nickel, we can find the impure nickel. So impure nickel is converted to NiCO4, then we will decompose it, we will get pure nickel. So coordination compounds are widely present. So coordination compound, I have not found anything that where coordination compound concept is not used. So coordination compounds are greatly present in biological system. The coordination compounds example, first one is the chlorophyll. Chlorophyll is very important. So in chlorophyll, the coordination compound of which so chlorophyll is the coordination compound of magnesium, not manganese. I have done the mistake. So chlorophyll is the coordination compound of magnesium, and as we know that chlorophyll is very important for photosynthesis. Now hemoglobin is the red color pigment, and hemoglobin is the coordination compound of iron, and it acts as an oxygen carrier. Vitamin B12 and cyanocobalamin, vitamin B12 or it's termed as cyanocobalamin, is the antiprocious anemic factors and is the coordination compounds of cobalt. Okay, it is a coordination compound of cobalt. So other compounds of biological importance with the coordination metal ions are enzymes like carboxypeptidase A and carbonic anhydrase, that is the catalyst of biological system. So other compounds of biological importance with coordination metals are enzyme. So coordination enzymes can also form the coordination compounds, like example is the carboxypeptidase A and second one is the carbonic anhydrase, and carbonic anhydrase is the catalyst of the biological system. Coordination compounds are also act as a catalyst by many industrial complex, by many industrial processes like rhodium and Wilkinson catalyst. So both are used as a hydrogenations of alkenes. So rhodium complex and Wilkinson catalyst, and they are PS3P whole thrice are HCl. So both are used as a hydrogenations of alkenes. Okay, and third one is that very important, this one. Third one is also very important, that is articles can be electroplated with silver and gold much more smoothly and evenly from the solution of complex. So articles can be electroplated with silver and gold. So articles can be electroplated with silver and gold much more smoothly and evenly from the solution of complex, that is AgCN2- and AuCN2- than from the solutions of the metal ions. In black and white photography, the developed film is fixed by washing with hyposolutions which dissolves the undecomposed AgPO to form the complex ion AgH2O3 whole twice 3 minus. So what is the second last point? That is, in black and white photography, the developed film is fixed by the washing with hyposolution. In black and white photography, the developed film is fixed by washing with hyposolution. The solution should be hypo. Washing with hyposolutions that which dissolves the undecomposed AgPO to form the complex, and that complex ion is AgH2O3 whole 3 raised to minus. Okay, there is a growing interest in the use of chelating therapy in medical chemistry. An example is the treatment of the problems caused by the presence of metals in toxic proportions in plants and animal system. There is a growing interest in the use of chelating therapy in medicinal chemistry. An example is the treatment of problems caused by the presence of metals in toxic proportions in plants and animal system. Thus, excess of coppers and irons are removed by chelating ligands. What are the chelating ligands? So excess coppers and irons can be removed from the chelating ligand, can be removed by the chelating ligand. So excess irons and coppers can be removed by chelating ligands. So what are the chelating ligands? That is the D-penicillamines and dysferoxime B by the formation of coordination compounds. EDT is used in the treatment of lead poisoning, and some of the coordination compounds of platinum effectively inhibit the tumors. So some of the compounds of platinum, and what are the examples of compounds formed by platinum? That is the cisplatin and other related compounds. So some of the coordination compounds of platinum effectively inhibits the tumor. Examples are cisplatin and the related complex. And in the summary, 2 points are given. So what are they? The compound provides critical insight into the functioning and structures of vital components of biological system. Coordination compounds also find extensive applications in metallurgy process, analytical and medicinal chemistry. So these compounds provide the critical insights in the functioning and structures of vital compounds. Coordination compounds also find extensive applications in metallurgical process, analytical and medicinal chemistry. Okay. Limitations of crystal field theory. So crystal field theory successfully explains the property of coordination compounds, that are the formation, the structures, the color and the magnetic property, and this is very important. Crystal field models has ligand, and ligand act as a point charge. As a result, anionic ligands fluorine, chlorine should exert the greatest splitting effects. What is anionic ligand? The anionic ligand actually found at the lowest end. That means the left side of the spectrochemical series. Anionic ligands does not take account the covalent characters of bond between the metals and ligands. So anionic ligand does not take into account the covalent characters of bonding. Anionic ligands does not take into account the covalent characters of bonding between metals and ligands. Covalent bond means there will be sharing of electrons, and that electron should be the unpaired electrons. Okay, the anionic ligands, some of the covalent ionic ligands are some of the weakness of the CFT, which are explained by LFT and MOT. What is homoleptic complex and what is heteroleptic complex? Homoleptic complex means in a coordination compounds where one type of ligand is present, that is the homoleptic complex. And what is heteroleptic complex? In a coordination compounds, when there is different type of ligands, when there are different type of ligands, okay, that is known as heteroleptic complex. Example is PT is NH3 whole twice Cl2. So there are two ligands. First one is the NH3 and second one is the Cl2. The strong field ligand and weak field ligands. The strong field ligands are CO, NO, NH3, and weak field ligands are halogens and water. For tetrahedral complex, its shape will be the tetrahedral because there are 4 ligands, and octahedral complex the ligand number will be 6, and there will be metals and ligand, obviously 6 ligand. So homoleptic carbonyl compounds, only in homoleptic carbonyl compounds only carbonyl ligand is related with these homoleptic carbonyl compounds. Homoleptic carbonyl compounds formed by most of the transition metals. Homoleptic carbonyl compounds formed by the most of the transition metals. Obviously, transition metal will be used in coordination compounds. So these carbonyl compounds have very simple and well-defined structures. Only one type of carbonyl ligand is used here. And some of the examples of homoleptic carbonyl compounds are homoleptic carbonyl compounds. Examples are tetracarbonyl nickel, that is NiCO4, and its shape will be tetrahedral. Its hybridization will be sp3. And now FeCO5, its shape will be trigonal bipyramidal, and its oxidation number will be 0, and its hybridization will be dsp3. Hexacarbonyl chromium, that is CrO6, its shape will be octahedral and its oxidation number is 0. For decacarbonyl dimanganese, there is Mn2CO10. Okay, so Mn2CO10, so it has no bridge bond and it is made up of two square pyramidal. Unit is joined by Mn bond, this is manganese bond, and it has no bridge bond. For octacarbonyl dicobalt, it has bridge bond and the number of bridge bond is 2. So for octacarbonyl dicobalt, the number of bridge bond is 2. Okay, the number of bridge bonds are 2. So for the octacarbonyl dicobalt, the number of bridge bonds are 2, and it has cobalt bond bridge, 2 cobalt, that is CO metal. Here bridge bond present, and for decacarbonyl manganese there is no bridge bond. But for octacarbonyl dicobalt, for octacarbonyl dicobalt there are 2 bridge bond. For decacarbonyl manganese there is no bridge bond. Decacarbonyl manganese bridge bond. Its shape is like this. Mn. Let me draw the shape where it's made up. Decacarbonyl dimanganese. Decacarbonyl dimanganese shape is that. I have written di, right? Decacarbonyl dimanganese. So Mn is there. What is mononuclear, what is dinuclear, what is trinuclear, what is tetranuclear? Nuclear means metal. So when one metal connected to one type of ligand, that is mononuclear. When two metal is connected with one type of metal, that is dinuclear. When three metal is connected with one type of ligand, that is trinuclear. When four metal connected with one type of ligand, that is tetranuclear. So what is organometallic compounds? Organo means organic, and organic deals with the carbon. So metal will be the transition metals. The compound in which metal is directly bonded with the carbon, that is the organometallic carbon. So there are two types of organometallic carbon. First one is the ionic organometallic carbon, and second one is the covalent organometallic compound. Okay. So ionic organometallic compound. So ionic means ions, and ions are of two types. First one is cation, second one is anion. Cation means positive, anion means negative. So ionic bond is present between the metals and carbon. Ionic bond is present between the metals and carbon. So R means the methyl group. Okay. So covalent organometallic compound. Covalent means there will be sharing of electrons. That electrons should be the unpaired electrons. Sharing of unpaired electrons. Okay. Covalent bond are present between the metals and carbons, and covalent bond are three types. First one is sigma bond, second one is pi bond, third one is the sigma and pi bond. For sigma bond means there will be single bond, and single bond means there will be, when there is two electrons, it will form the single bond, and obviously every time there will be two unpaired electrons. Two unpaired electrons needed to form a single bond. So sigma bond is present between the metals and the carbons. So CH3,4SN is the examples of. So we can find the number of sigma bond between the metals and the carbon. Example in tetramethyltene. So tetramethyl, methyl is the CH3 group, that is the R group, and tene means SN. So there are how many tetramethyl? 1, 2, 3, 4. So there are 4 sigma bond, And for RNGX is the organic compound, that is the Grignard reagent, and RNGX there will be 5 sigma bond. Pi bond is formed when there is double bond, and when there is double bond there is one single bond, and 2 pi bond. When there is triple bond there is one sigma bond, 2 pi bond, and when there is single bond there is one sigma bond and 0 pi bond. Ferrocene example. So ferrocene Fe into the power 5 C Fe into the power 5 C5H2 whole twice. So ferrocene is formula will be Fe into the power 5 Fe into the power 5 C5H2. Fe into the 5 C5H2, and its hepticity will be 5. Hepticity means the number of carbon in rings or the linear chain. So dibenzene chromium. So dibenzene chromium is Cr into the 6 C6H6 whole twice. So number of hepticity will be 6. For this salt formula is K potassium PTCl3 into the 2 C2H4. So its hepticity will be 2. Sigma and pi bond is occur between the metals and the carbonyl compounds. Okay, yes, I've read this. Bond in carbonyl compounds. So to form a bond we need metals and carbonyl compounds. So bond in carbonyl compounds, so we need metals and carbonyl compounds. And in metals there will be 5 orbitals, and out of 5 orbitals 1 orbital should be the vacant orbitals and 4 orbitals will be the fulfilled orbitals. And there will be d orbital shape, that is d dumbbells or the double dumbbell shape. Okay, then the carbonyl compounds mean in carbonyl compounds there should be one lone pair, and when there is one lone pair there should be 2 electrons, and 2 electrons form the one single bond, and one single bond is formed when there is 2 electrons, and it's needed pi antibonding orbitals. Metal carbon sigma bond is formed by the donations of one lone pair from the metal carbon sigma bond. This is the sigma bond. So sigma bond is formed when there is head-on overlapping. Obviously, that's it, right? So metal carbon sigma bond is formed when there is head-on overlapping, and metal carbon sigma bond is formed when there is a donations of one lone pair of electrons from the carbonyl compounds to the vacant d orbitals of the metal. And metal carbon pi bond is formed when there is donations of lone pair from the fulfilled d orbitals of the metal to the vacant pi antibonding orbitals of the carbonyl compound, and there should be sidewise overlapping and back donation pi bond. And this will create an effect. That effect is the synergic effect. So the metal to ligand bonding creates the synergic effect, and it strengthens the bond between the carbonyl compounds and the metal. So synergic effect, for synergic meaning is the carbonyl compound, that is CO, and CO is the carbonyl compound. CO is the carbon dioxide. We can say, not carbon dioxide. CO2 means the carbon dioxide. CO means the carbon monoxide. Di means 2 and mono means 1. So CO is here. Our number of oxygen is 1, so it will be carbon monoxide, and it is the strong field ligand. It has acid pi ligand, right? Yes, acid pi ligand. So it is the acid pi ligand, and acid pi ligand is formed when it is vacant antibonding pi orbitals. Okay, then synergic application of synergic effect. Metal carbon bond. In metal carbon bond energy increases, bond order increases, bond length decreases, and the charge densities on metal carbon bond will be for metal negative greater than 0 greater than positive, and for CO bond energy decreases, bond order decreases, bond length increases. That will be positive greater than 0 greater than negative. And synergic effect has bond, and its difference should be minimum. One thing I have missed to revise, that is when there is transfer of lone pair from the fulfilled d orbitals of the metals to the carbonyl compound antibonding pi orbitals, so electron is transferred to the pi antibonding orbital, so bond energy decreases because the electrons are transferred to the 5 orbitals. So the formula of bond order is Nb minus Na by 2. So when we put the formula and the negative and the result is negative, so the bond energy, so bond order decreases, not an Do you know that in the summer season in West Bengal, so there are mango season. I like mangoes. So when I consume mangoes, I feel so sleepy that you even can imagine. Every day I consume four, minimum 4 mangoes, and highest is 7. At one time I can consume, means I can eat 5 mangoes, and mango size is big only, not that much small. What is infinity? Infinity is the relative term. So 1 meter length is infinitely large as compared to the radius of atom. So what is the radius of atom? Radius of atom is 10 to the minus 10 meter. 10 to the minus 10 meter, yes. Radius of one atom equals 10 to the minus 10 meter, or 1 Armstrong. 1 Armstrong means 10 to the minus 10 meter. The radius of one atom is equal to the minus 10 meter. 1 meter length infinitely small is in comparison to the radius of the earth. So the radius of the earth is 6400 kilometer. What is the value of E? 2.71. Yes, I forgot. I'm not forgotten. So anything 1 by infinity is equal to 0 in the term of physics, and for maths it will be undefined. For mathematics it will be undefined, for physics it will be 0. also I revised my basic maths. Tomorrow I will revise this chemistry. The back means I have up to which portion my teacher taught. I have revised, but due to some programs in my house and in my relative house, I cannot study properly. So I have to cope up with that also. Those who are new, please subscribe my channel. From 7 a.m. I am having class. Oh my god, what happened? Please speak Hindi. मेरी हिंदी इतनी अच्छी नहीं है, so I can speak little bit. आप कहाँ से हैं जी? आई एम फ्रॉम, मैं वेस्ट बंगाल से हूँ. हम राजस्थान से हैं. प्लीज सब्सक्राइब माई चैनल. जो भी those who are new, please subscribe my channel. मैं बहुत दिन से पढ़ नहीं पाई क्योंकि मेरे घर में प्रोग्राम्स थे, रिलीजियस प्रोग्राम. Now I have to cope up with many things, many lectures are left. हाँ कर दिया मैडम, थैंक यू. किस जॉब की तैयारी कर रहे हो? नीट एस्पायरेंट्स हूँ. आई एम प्रिपेयरिंग फॉर नीट एग्जाम. कुछ दिन से ठीक से पढ़ नहीं पाई क्योंकि रिलीजियस प्रोग्राम थे घर में और बहुत सारे प्रॉब्लम थे, इसलिए बैकलॉग्स हो गए. नॉट बैकलॉग्स, आई हैव कंप्लीटेड माई, आई हैव सीन माई एवरी क्लास, बट पढ़ नहीं पाई अच्छे से. I have to memorize everything now. So that thing is left. I have 3 classes daily. So before joining class, I should revise everything. Plant kingdom up to algae. मैंने YouTube ओपन किया तो आप वीडियो आपका वीडियो आ जाएगा सामने. ओके. रिविजन. I'm writing my routines now, what I will do next day, because though I cannot study properly, so I have to cope up with that everything. I have to read everything. सेवन एम क्लास है तो रिविजन कर लूँगी. प्लांट किंगडम चैप्टर्स कंप्लीट कर लूँगी. रिविजन. PM bio class from 3 PM, so 4 to 5. From 4 to 7 I have time to read chemistry. छुट्टी है. इंग्लिश थोड़ी बहुत आती है, ऊपर से जाती है. मेरे को हिंदी थोड़ी बहुत आती है और समझ में आती है और बोल नहीं पाती थोड़ा सही से. सेवन एम physics class, then I will revise everything, then I will do plant kingdom bio class, 2 PM bio class, then I have time from 4 to 7 I will revise chemistry. So I have completed my today's task. From next day I will be alert and indulge in studies. Two bryophytes block plant succession. So bryophytes are called amphibians of plant kingdom because they can survive in soil and they depend on water for sexual reproduction. So bryophytes are called amphibians of soil. Amphi means dual. Dual. Yes. They are called amphibians because they can live in soil and they need water for their reproduction. And they usually occur in damp, humid, shaded localities. They play important role in plant successions or bare rocks. Actually, lichens produce acid on rocks, and that rocks convert it into soil, and from there, bryophytes grow. Plant body of bryophytes, it is more differentiated than algae. That means it is more complex than algae. It is thallus-like. Thallus means what is thallus is written in what is thallus. Yes, thallus means not having true roots or stem or leaf. They are having root-like, leaf-like, stem-like structures. So it is thallus, root-like, absence of true roots, leaves and stem. It is prostrate and erect. It is prostrate or erect. It attaches to the substratum by unicellular multicellular rhizoids. It attaches to the substratum by unicellular multicellular rhizoids. Unicellular are liverworts and multicellular mosses. They lack true roots, a stem or a root. They may possess root-like, stem-like, or leaf-like. Main plant body of bryophyte is haploid. So gametophyte is haploid. Gametophyte produce gametes, and gamete is also haploid. When two gamete fuses, it will form zygote, and zygote is diploid. And when zygote do mitosis, it will form sporophyte. Sporophytic, that is sporophytic stage. Sporophyte stage. And sporophyte stage is multicellular. It is diploid, and then it will go meiosis. After meiosis, it will form spores, and it will do again mitosis. Then it will go undergo gametophytic stage, and gametophytic stage is haploid. 6 organs of bryophytes are called multicellular or sporophyte. Haploid plant body produce gametes, and they are called gametophyte. आज रोज आते हो कि लाइक हाँ रोज आते हो green algae, brown algae and red algae. So examples of green algae are Chlamydomonas volvox, Psilocybe, Spirogyra, Chara. Chlamydomonas volvox, Psilocybe, Spirogyra, Chara. Ecocarpus dentatum, Hadmenus, Acrosophilus, Porphyra, Polycyphonia, Porphyra, Glaciolinium, here used as it's called hydrocolloids, agar. It's a commercial product, and agar is obtained from Hymenaeum and Gassera. Hymenaeum and Gassera used to grow microbes in preparations of ice creams and jellies. And what is Florida? It is unicellular algae. It is rich in proteins. Florida used as a food supplement even when space travels. Those one you please subscribe my channel. I will end my live stream today because I have class from 7. ओके ठीक है बाय आप स्टडी करते हैं मिलेंगे कभी बाद में ओके थैंक यू एंड